to join the hangout here.
Very good. That'd be awesome. Yeah, I'm going to start getting some folks to come to the hangout too. And so I wanted to chat a little bit about some developments. So one of the things that is really hot in terms of the RChain stuff that's important is kind of the correct by construction version of Casper. And Vlad has been looking at a safety calculation. So when is an estimate safe as a part of the axiomatic framework that we laid out for reasoning about consensus protocols. And what we've been talking about over the last few days is refactoring that construction as an inference system. So or a deduction system. So and the aim for that is to tame the complexity. Right now, the way Vlad has the calculation, even just for a lower bound, the complexity is equivalent to knapsack, and that's somewhat problematic. But if you take this compositional approach that I've been advocating for quite some time, then you have the possibility of taming some of the complexity. So that's what I've been working on. Let's see if I can try to make that a little bit more concrete, especially since we're recording and people might be watching afterwards. So let's go here and and we go here. Let's go with Optima. Okay, so what we're considering when we do these safety calculations is what Vlad calls them a fault context, and then so I'm going to represent that with the symbol C. And then, let's see if I can go grab these.
You want to share your screen, maybe?
Yep, absolutely. 1 second. Just grabbing up. So the situation is one that looks roughly like this. We have a network of validators. And we explicitly model the communications network as a process N. And then the validators are parametric in channels V. And then in between each validator, we have some gates. And the gates represent kind of so you can represent network communication faults by transitions in this process, and they can represent other kinds of failures as transitions in the gate process. So this is roughly the kind of thing that we're considering. So when a validator, say V1, wants to send a message to V2, it sends it to what it thinks is the network, but in fact there's a gate between it and the network. And that gate is what translates the communication that's along channel V to something that's along channel N, one of the N's. And then likewise, when the N goes up to the N that it's selects this one, and then that gets translated to the right V here. And so these two can simulate various kinds of faults or malicious attacks. So this is kind of the setup that we're talking about. And in the context of this setup, I'm just looking for little symbol. Here we go. Wonderful. And 2 favorites. Okay, so move this over here, and then, oops, select that, duplicate, and so I'll get rid of this maybe. And then just go and grab a new font. Let's say Optima. So when we talk about a fault context, and the fault context is really of the form, it's an assignment of validators, say V1. Oh, wait, before I do that, I better put a comment in there. Sorry. Say V1. And that assignment would be to await and whether or not the thing is innocent or Byzantine. So that's and then there'll be a bunch of these. Sorry, this will be wait 1. And then call this K. Okay, where there are K validators, or at least K validators in that fault context. So that's kind of the shape of these. To do that recursively, what we would do is it's either the empty context, say open close, or it's one of these. Const onto a C. Right, so hopefully that notation makes sense. What we're saying is it's a recursive spec. So either a C is the empty context, or it's an assignment of a validator to a weight and a judgment about whether it's innocent or Byzantine, const onto a context. So there's the recursive definition. And then what we're saying, that the judgments that we're looking for in this little deduction system are of the form, that's weird. Why is it not? Oh, there, okay. Are of the form C thinks that, so that little symbol can be read or pronounced as thinks that. So C thinks that a view, I've used V in 2 different ways. So let me use for a view, H. So we'll use H. H semicolon E is safe. Okay, so I need to tell you what an H is. So I'll give again a little recursive spec of what H's are. So an H is either true, or it's the negation, or it's the negation of an H, or it's a conjunction of H's, or it's a B, and then a B is open, and then you have sender spec a estimate spec and a justification spec, and then a sender spec is going to be very much like your C's, like the H's. So it can be true, which would indicate all of the validators. It can be tilde S, which would be the complement of the set of validators that we're considering, or it can be an intersection of two sets of validators, or it can be a validator address. So that's S, and then E is, again, just like this, but here, instead of the address, it's the domain value, which we'll just say for now is Boolean, right? So this is a binary consensus algorithm, and they're just working on Booleans. And then finally, so this would be E, E, and E, and then we would have the justification spec, which is a little bit more complicated. So it's going to be these, or it's the null justification, or it's consing a bet spec onto a justification spec. So what this says is that you have justifications are lists of bets, and this gives you the ability to build specs of lists of bets. So then, just to be clear, a bet is always of the form sender estimate justification, and a justification is really just a list of bets, and the bets represent what we've seen so far. So that's the shape of these. So this completely describes the shape of these things, where again, E's are taken from the domain of values over which you're consensing. In this case, in the simplest case, it's binary. So what we're doing is we're really writing down a deduction system that corresponds to the recursive definition of the safety calculation. And the axiom is, for this deduction system, looks basically like this. In a null context where we don't have any information about who is Byzantine and who is not, then what we can say is when it is the case that all of the validators, so this is going to be if I use A to range over all the addresses, so this is A sub I, comma, E, where E is little b, where little b is one of a Boolean, specific Boolean, either true or false, but one of them. And then the justification is null. And then here what we need is math symbols. Oh, we'll use coproduct. So this is I subscript and then here there we go. So this is the axiom, and what this axiom says is if all of the validators provide the same estimate B, then the estimate B is safe, right? So if spontaneously, without any history, they all bet that true is the case, then B is safe. That particular, then true is safe. And now, so that's the axiom. And then what we're looking at are different inference rules. And those inference rules, so if we say that a justification, say, a judgment, which is of this form, is, so let's say that this is R, then what we want is an inference rule, which is going to be some judgment, say R1 through Rn, allows us to conclude R. And then okay, and essentially what we're looking at are different. So Vlad has a particular calculation here, but it's not recursive. And what we're talking about is, given that these validators, we're able to conclude that these validators with this particular fault context in view believe that estimate E1 is safe, all the way up to this other group that believes that estimate En is safe. Then how do we update their fault context and views so that we get, essentially what we really want is that one of them changes its mind. And what that will come down to is that the weight of the Byzantine free subset is greater than the weight of this particular validator. And its view of those is that they are Byzantine free. So its fault context is that these guys are Byzantine free. And so then it will be able to update its particular view in that fault context. So this gives us a compositional view of how to calculate the safety, and allows us to write down the safety as a series of proof steps. And the reason that's important is that at the next level up, we can turn these judgments into, we get relationships between these judgments and terms, pi calculus terms or Rolang terms that talk about these kinds of safety calculations. So in particular, we will then have these safety calculations related to terms that look like this. So a term that looks like this is kind of an innocent validator. What this validator does is it cases off of, it's expecting input over a range of channels V. So this dark bolded vector V is really a series of channels, V1 through V, I don't know, L, right? And then for each channel VI in that range of channels, we're going to pattern match on the bets that come in over that channel. And in the case that the bets that come over the channel match a particular spec, right? So where do these specs come from? Well, if you look back here, that's these kinds of things here. So a spec looks like an S, E, and a J, or these are possible specification patterns here. So depending upon the kind of spec we get here, then we're going to calculate a new estimate for example, we would update the estimate to be the estimate of the Byzantine weight for Byzantine free, the greatest weighted Byzantine free estimate, and then broadcast those out to the rest of the validators. That's what this big pie is here. So it's a parallel composition of each of these message send events. And the picture that goes along with that is, say, V1 receives information, V2 receives information from V1, and then it calculates a new estimate and then sends out to each of the VIs its updated estimate, because that the bet that it received, sort of matched this spec here, which then allowed it to update. So these kinds of programmatic definitions can be related to these inference rules that say something about the safety of the estimate. So in this way, we're building up a sort of standard programming semantics type theory style approach to the Casper calculation that is in alignment with the whole behavioral types framework and in alignment with the design of Erlang itself. So we reason about, so again, just to summarize, we reason about the model in terms of Erlang, and that reasoning about the model becomes the code for our implementation, and that code, which looks like this kind of thing, is directly related to our ability to make judgments and inferences about the safety of, or about how, whether or not the consensus is correct and converges. So that's the shape of the that's the shape of the development that Vlad and I have been working on. I know it was long-winded, but that I just wanted to give an update on that so that people can see that work on Casper is proceeding within RChain, within the RChain project. And let's see, there are a few other things that I wanted to mention. One, let's go back to, so David Curran asked some interesting questions. Let's see if I can figure. Okay, so David Curran had asked, how will stored data be retrieved? Will it be via special case style queries, or will it be some kind of network address system where content can be retrieved via static address? So that question is important. The simple answer is that the plan is to use special case style pattern queries. So rather than having fixed locations for data where data is penned to a physical storage, we have an abstract location mechanism, which are the special case style queries, which can be and that's important in a dynamic network like a blockchain, where the physical storage can come up and go down. The physical nodes that are supporting the network can come and go, but the data remains persisted. So to be more clear about all of that, let's take a look at how special K looks currently. This will be updated as we move to RChain, but here's how special K looks currently. Let me grab one of these. And so when you're retrieving data from the network, so for data from, now what is a source? Well, a source looks like a node. So you have to have an entry point into the network. And then you have to have a connection. And then you have to have a pattern. Okay, so that's what's necessary in order to get data off the network. And once you've issued that query, then you can run some program P that utilizes the data. So let's compare. So let's look at this.
Can't see your screen, Greg.
Oh, sorry. Did I stop screen sharing? Thanks. Okay. So here's the shape for retrieving data in Special K. So you're asking for data from this data source. Now, what is that data source? Well, the data source breaks down into a node, a connection, and a pattern. And so you can, now let's compare that to a URL. So we typically have a scheme like HTTP, and then we have a, oh, that's weird. I don't know what that, stop. And then we have a host and a port, and then we have a path. Okay, so you can think of pattern as generalizing path. You can think of node and port, host and port as like node, and you can think of connection as essentially it doesn't, you can think of it as part of the path, but it doesn't have quite the same sort of analog as over here. Here we don't have the notion of scheme separate. I mean, in some sense, you might consider connection as a part of scheme. That might be a way to go about it. But the big differences are that pattern is a tree pattern, not a path pattern. And that's important when you want to be able to combine patterns, like combining paths. It's hard, it's not always possible to combine paths in ways that you get back a path. It is, since every path is a tree, and it is always possible to combine trees and get back a tree, then the right, or a model that satisfies compositionality as a desiderata is that these things ought to be trees. And that's what we provide here. So this kind of addressing scheme is, in our opinion, sort of mathematically cleaner, mathematically better. It also gives lots of other capabilities which are not available here. So in particular, there can be variables in here. And so you can match multiple different locations rather than a single location. So you can go and grab multiple different resources rather than a location that's at the endpoint. And that, by the way, so by unifying the query mechanism with the resource location mechanism, that differentiates this from, not only from HTTP, but it differentiates it from IPFS. So our mechanism here is designed from the beginning. I mean, I was designing this before IPFS ever existed. I didn't know about IPFS until end of 2014. And you can see that the code for Special K has been committed since 2010. So this is built around an observation, well, several observations from the literature. In particular, when the fact that these patterns are prologue terms is because we're being influenced by the applied pi calculus. which essentially enriches the pi calculus with Prolog terms. But also, Milner has a somewhat obscure paper which he calls naming monoids. So in particular, what he's looking at is in a very, very abstract characterization of the process calculi, which he called action calculi, which would, and again, to place that, that work informs his work on bigraphs and informs the work that I've been doing with Mike Stay on the two categorical representations of the process calculi. So there, when you look at the names that are utilized for channels, he arrives at a characterization of the algebraic structure of those names. So the internal structure of names, and comes to the conclusion that they more or less have to look like trees. That he gets a kind of representation theorem that says they have to look like trees. So when you have, so just to be super clear about this so people understand what I'm saying. So you have here one area of research, the applied pi calculus. That suggests that this thing here is usefully thought of as a Prolog term. And then you also have Milner's results from the action calculi, so the naming monoids results also suggest that that thing is usefully thought of as an abstract syntax tree that looks remarkably like, let me just get another shape in there. There's no fill. There we go. That'll be easier to.
The context, Greg, for the question that I put there in the storage channel was really about, like, I was kind of wondering whether there was whether it was possible to kind of treat this as a static name, like in just for the purposes of the kind of thought exercise I was doing as I was thinking about how to implement something like, a distributed source control system or something like that on top of scenario. And in that case, I was thinking about, addresses.
Yes.
With any kind of content storage system, you end up thinking about addresses. And so I was really, that was kind of the context of the question. I was wondering whether there would be some kind of layer, address layer, which allowed you to, to access, obviously, to access content in that way, where it looks like there is some relationship between, the query pattern, obviously, and, and a path, which we're more used to.
So if you look at,
or is it something you're going to have to kind of build yourself? Because you could also build this abstraction yourself, couldn't you?
Well, the abstraction already exists. So if you look at the implementation of Glossavel, which is providing a kind of CRUD-like API for the user model on top of the agent layer, it does exactly what you're talking about. So there are well-known connections and patterns for information that needs to be available to a particular scope of agents.
Okay.
Right. So it's being treated exactly as well-known addresses.
Okay. I haven't looked at Glossavel. I wondered what that was, to be honest.
Yeah. So Glossavel was essentially, it's the HTTP bridge into the agent mechanism, and then because we were working with programmers who didn't sort of grasp the significance of the PyCalculus API, we added a CRUD style API on top of it in order so that things would be easier for them to understand. And so you can see that there are these sort of well-known patterns or addresses, as you are thinking about them, to access distributed content.
Mm-hmm.
Right, but what I was trying to say was it's a lot richer, right? Because you can have well-known queries. So one thing that's really important to understand is the connection is the more fixed thing. You can get into, this is like your entry into the network, just like host is in HTTP, host is really not where the resource lives, but it's your first best guess as to where the resource lives. Because if you look at the HTTP protocol, you come in at this host and it says, and this is what, I don't really have it, but there is some other host over here who does. Mm-hmm. Right. And that's kind of, or actually, sorry, in HTTP, you start off as sort of the closest host, and then you find a path to this host and then get the resource there. But this is slightly more general, which is you come in at this host, and this host is connected to a range of this node is connected to a bunch of other nodes, and one of them will be able to get you to the connection and pattern where the resource lives. And in particular, the resources that are sitting off of these are swimming in that sea of nodes, right? They're not actually, it's not physically located on a particular node. It's swirling around this set of nodes.
So in that case, is the node is doesn't have all so you don't necessarily need a node as an entry point, because the node may not. What happens if the node's not available or not up or?
Right. Yeah. So first of all, in order for this code to be run at all, there are guarantees about the availability of this node. But the node, but you're right. The node, a node where this is initially deposited may not be up. But that's why it's important that the data is swimming around. And then the next step is adding what I was talking about before, which is the Casper protocol, so that you have consistent replication semantics. That's essentially what consensus is providing, is replication, so that all the data can be consistently replicated in a sharded fashion. So essentially, proof of work and proof of stake are availability protocols. Right. That's what they're doing. They're saying we can make sure that everybody has the same data in a decent.
So in that case, we could probably read node as something like network.
Yep. That's yes, exactly.
Okay.
That's and in that sense, node is kind of like scheme. Mm-hmm. Right. And the more stable thing is connection. Right, connection is really it's sort of the root of the path to the connection is where you start making sense of the path. I tend to disagree with Juan Bennett about the need for special elements in the path. In particular, I do believe that there are special roles of roots, which we see played out time and time again. Which is, it's why HTTP evolved to the form that it did. It's why, there are, there really are differences between, roots in Unix that are mount points versus, versus file handles versus these kinds of things, right? So there are differences, and I tend to feel like that has to be, it's best if that's syntactically supported for analysis.
Right. Well, it's the reason why we don't just use IP addresses, right, as an addressing system on the internet.
That's exactly right. You're spot on, right? So paths as an abstraction is kind of a nice beginning point for people to think about, but it's not where we end up. Mm-hmm. Trees are where we end up, and the roots of trees are kind of important. And that's so that you can have a unified notion of query, and a way to dispatch on type when it comes to different semantics beginning from a particular root. So that's that kind of, hopefully that treats your first question.
Yeah. Well, I wasn't, to be honest, really expecting, necessarily answers to those. They were just kind of, placeholders or they're definitely queries that I have, but I wasn't necessarily expecting them all to be answered.
Yeah, no, I understand, but I think it's actually, I think this kind of dialogue and discussion is really important. And I think in just in this, there was this opportunity for people who maybe haven't come to the project before and who might come to this video to understand, A, what we're doing, and B, kind of more importantly, what has gone into the analysis. I have literally, I've literally spent, decades thinking about exactly this problem. And not just in the academic setting, but also in the industrial setting, right? When we were doing BizTalk and we were looking at WSDL, and we were looking at a wide range of other W3C standards, these were the kinds of questions and considerations we gave to those designs. And that's the kind of research and experience that's gone into the design of Special K, so that you have an addressing and query mechanism that fits with the overarching programming model. And that overarching programming model is something that programmers can understand. Every programmer understands a for loop, right?
But this means that you have to access content within the programming context. It's not like you can just think of something as an address which you can paste into a browser, to access a piece of content that it has a physical address. You have to have a programming context in order to be able to construct the query, in order to be able to pull the content out, right?
So I think that's an interesting discussion. From my point of view, I can decompose this into its bits and pieces. Like, here's an address, right? Or maybe slightly more completely. I can certainly think of this as an address, node connection pattern, right? And I could certainly take that and plug that into a context, right? So
right.
here's a query context. So if I say,
so for example, your GitHub, user and repository, that pattern as a pattern for accessing a unique, repository belonging to a particular person on online. And that's the kind of problem you'd have to solve if you were going to implement some kind of, some kind of version control. You need to have some kind of concept of namespaces where repositories.
Exactly. Bingo. That's exactly right. And the same thing. So if you look here, there's my context K, right? Mm-hmm. There's my address. I should have done it that way. Let me redo this. So this is adder node, adder connection, and adder pattern. And then I can think of the rest of this as a particular context, right? And so when I if I set K of adder as equal to that, now I can think of address and programming context as separate but pairable, right? And in fact, I can go one better, right? I can parameterize this and say, put P in here, right? And now the whole thing, and this is in point of fact, exactly how the CRUD API in Glossaval was designed.
Okay.
Yeah.
Right. Yeah, that makes sense. So I should. Yeah, that makes sense.
Right, and this is, you know, so if you think about it from the point of view, so let's call K instead of K, let's call this accessor to make it even more, and then here it's the callback, like on value, right? So now it looks just like JavaScript, which is the kind of people we were working with initially, right? So now it looks just like the usual, and then sorry, this becomes then on value, and now the, you know, there's this trampoline from the way people think about it in Node.js land versus the way we're thinking about it in a strongly typed setting where, you know, we have this relationship to the applied pi calculus and so on. And I think that that's important, right?
It's very nice.
Cool. No, I mean, and I'm like really grateful to you for asking these kinds of questions, because it helps us drive out all of these things, which, you know, a lot of people don't know, you know, are a part of the design of the RChain mechanisms. So let's see. You had a couple of other ones that I thought were really interesting as well. So compensation for bandwidth use. Yeah. Okay. So that's kind of really important. And I'm not going to claim I have an answer. But in particular, one of the things that I've been working towards is how that relates. I think that a proper answer has to relate that to streaming. You know, right now, the content model that we're looking at is not well suited to, or at least I don't know how to do streaming style content like video and audio, and that's going to have to. I know that it's possible, but I haven't thought through an architecture that I would be satisfied with in terms of performance characteristics and guarantees. But that has to relate to compensation for bandwidth usage. And I think that's probably, well, I don't know yet, but that seems to me to be one of the natural levels at which to levy that kind of charge. It's like, you know, because people can understand it. They understand, well, if I'm downloading this many videos, then this is the kind of cost. So not just in terms of the actual storage of the video, but in terms of the bandwidth that's being utilized. So that's one approach. I mean, I would consider myself fairly naive in this area, and I'm looking to work with others who have good solutions here. So availability for less popular content. Yeah, so this plugs into the whole rent model, and so it also plugs into namespacing, right? So the hope is that there ends up being that content naturally gravitates to namespaces that are more or less indicative of their use, if that makes sense. So you have a namespace for highly popular content, and you have namespaces for less popular or more niche usage, and if you have, and the reason that's related to this question is, if you have that, then you get a natural relationship between sharding, which is part of the availability guarantee story, right, and content, and so that's sort of the broad strokes picture.
Mm-hmm.
Is there?
Yeah. Yeah, well, the context for that question was, again, like, it's just, if we're going to move from a centralized model for storage of data to a distributed model, then the distributed model has to provide the same kind of guarantees that the centralized model does, right? So,
right,
or the same kind of performance characteristics.
yeah. I think we have to be really careful.
If I've got some file that I care about, and I upload it to to S3, I expect it, because of the guarantees that they provide, to be there when I come back in 5 or 10 years time.
Yeah. No, I agree. Well, actually, I mean, I really, I strongly believe in rent here. I think that rent for data is super important, because it means that if folks are not engaged, then there can be this, and by engaged meaning they're paying monthly rent or whatever, periodic rent. Then you have a strong indication that you can roll content off to, I mean, the way I would like to think about it is in terms of garbage collection, right? So, think about, you've got a kind of generational scavenging garbage collection that's internet scale. Right? I mean, so you've got a notion of old space and new space, and maybe lots of variants of old space and new space, right? So older still, oldest, that kind of thing, and again, that can be related to sharding, because now you've got an actual namespace scheme that's related to age of last known access, or aid, or whether or not there's a pointer. There's something that's continually, like a subscription would be the equivalent of a pointer. If there's an ongoing and actively used subscription to a particular range of content, then that content can be considered stable. If there are no subscriptions and no ephemeral accesses to the content, then it's subject to rolling off and archiving, and eventually garbage collecting. So that's the model that I have in my head. And again, I'm happy to discuss the merits of that approach. It's 12:01. I got to get to dev stand up, but I really appreciate this, and thanks, Christian, for your work setting this up. And hoping to see if you think that there are other HJ, I appreciate it if you get our Pirate Party friends to join the party. And David, if you have folks that you think might want to join the conversation, that would be great. I think it's, the more lively and active we can make this conversation, then the more these kinds of questions will come up, and we'll be able to have meaningful and substantive interchange. Okay, I gotta go.
All right, man. Later on.
Talk to you guys later. Ciao.